All right, rational expressions. Rational expressions are fractions. That's what we got to know. Okay. Our job today is going to be simplifying rational expressions, and then we're going to multiply and divide them as well. It's the same skill whether you're simplifying or multiplying or dividing them. It doesn't change according to that. So let's start with some simplify. We'll start with, like 5th grade math. How do we reduce that fraction? Yeah, you find something that goes into both of them and then divide them each by that. Usually you try to find the biggest thing that goes into both of them and divide by that. So with 24, 8 goes into it, 8 goes into 56. So this is really what's happening when we do that. We usually just divide it and like cross it out, put the number beside it, something like that. But this is really 8 times 3, and this one's 8 times 7. What's happening here is that common factor of an 8 is canceling out. That's what we're doing. We don't ever show it this way, but this is what we're doing. And that creates this 3/7. That's what that fraction reduces to. Now, where that comes back into what we're doing today is we're going to have x's, and we're going to have things with x plus 1 in there and several factors going on. And we've got the idea is you're canceling matching factors. So if we just remember that idea, we're going to be okay. Even though that's not how we normally do number fractions. When we get the polynomials in there, we got to think about it that way. So like, let's do one, step it up just a little bit, maybe algebra 1 level, 12x squared over 16x. And the 12 and the 16, I think we know how to do that. What goes into 12, it goes into 16. 4 goes into both of those. And then how many x's could cancel out? 1. Okay, so 4 goes into 12 3 times, and into 16 4 times. 1 x down here cancels out one of the x's up there, leaving an x in the top. We've simplified that rational expression. That's the gist of what we're doing. Let's step it on up to maybe even still algebra 1 level, maybe, but getting more complicated as we go. So here's a factored form of polynomials involved, and we want to look at canceling matching factors, just the same way we were doing with the others. We were canceling matching factors, but we kind of didn't show it. Here, it's easy to show. What's the matching factor? X plus 4. So those two are going to cancel each other out. It's going to leave 3x over x plus 3. This x with the 3 on top cannot cancel this x down in the bottom, because these two are tied together with addition, and you can't cancel pieces that are tied together with addition. You can only cancel whole factors. Like this whole factor, x plus 4, was matching this whole factor, x plus 4. So you can cancel those two together, but you can't cancel this 3 and this 3, because this 3 is tied together with addition or a subtraction. So addition and subtraction, you got to think, okay, I can't just get part of that. I got to get the whole thing or nothing. All right, so keep that in mind as we go along here. So there's the simplified form of that fraction, or rational expression. Excuse me, I don't want to scare you. Say the word fraction. So when we get to maybe more of an algebra 2 level, they're going to give us the problem maybe like this: x squared minus 2x minus 15, and then x squared minus 9 in the denominator. And we look at that and we say, okay, well, this x squared is tied together with a subtraction. This x squared is tied together with 2 subtractions, so there's no way I can cancel those two. The 9s and the 15s are tied together with subtraction, so no way to cancel those. But we see quadratics. And what do we know we can do with quadratics? We can factor them. So let's factor the numerator and the denominator as much as possible. That's the goal with these rational expressions, is factor everything as much as possible. So the numerator, the trinomial, so I'm going to think x method, negative 15, and multiply to be negative 15 and add to be negative 2. Yeah, negative 5 and positive 3. So the factors are x minus 5 and x plus 3. And then what does x squared minus 9 factor as? Yeah, x minus 3 and x plus 3, no matter what order you put that in. And then we see a matching factor involved there. So cancel those two out and get x minus 5 over x minus 3. And we can't cancel these x's again because the subtraction ties it to the 5. The subtraction ties it to the 3. So you can't untie that without factoring. And so the factoring is going to be the difficult part. The canceling is the easiest part. That's the part that if you can factor, simplifying is easy. If you're not really great at factoring, you're going to get plenty of opportunity to get better at it today or this next couple of days. X squared minus 8x plus 16. And then let's do another trinomial, x squared plus 2x minus 24. I'm thinking they're going to factor that way. Top one. Multiply to be 16. Add to be negative 8. Yeah, negative 4, negative 4. So my factors are x minus 4 and x minus 4. You could write that x minus 4 squared. I don't think it helps you here to do that. So I usually don't rewrite it until I go to my final answer. If there's a couple of them, that don't cancel out, then yes, I do usually write it that way. But in the simplifying steps, I don't ever write it out in that way. Denominator. Yeah, multiply to be negative 24, added to be 2, be 6 and negative 4. So that'd be x plus 6, x minus 4. How many x minus 4s can cancel? Well, how many are there on top? And there's how many on bottom? 1. So it's a 1-to-1 cancellation. So this 1 can only cancel 1. Okay? So that leaves this guy up top. So it's only a 1-to-1 cancellation. So the x minus 4 in the bottom can only cancel the one of the x minus 4s in top. So we're left with x minus 4 over x plus 6. Not too complicated so far. We'll get to more intense in just a little bit. But example F. Let's do this. 40x squared plus 20x over 10x plus 30. Maybe a little different style of factoring here because it's not trinomials. How do we factor those? Yeah, the GCF out of them. That's what Tucker was going to say too. What's the GCF of the numerator? 20x. What's it leave in the parentheses? 2x plus 1, yeah. Then in the denominator, what's the GCF? No x? Just 10? All right, good. That's right. That leaves x plus 3. All right. Now, our polynomial part there doesn't have anything. They're not the same. So can they cancel? No, they're not the same. So they can't cancel. What can cancel here? The 20. Does the x even involved? Does it do anything? 20 and 10 could cancel a little bit there. How do they cancel? Yeah, 10 goes into itself once and then 20 twice, right? So that leaves us a final thing of 2x parentheses 2x plus 1 over x plus 3. And today, and probably for the next couple of days, we'll leave them in factored form. You usually don't have to multiply it back out. once you've simplified it, just leave it in the factored form like that. You usually don't have to multiply it back out. Okay. Say we had x squared plus 6x plus 8 over x cubed plus 64. So the numerator, back to the trinomial. So let's factor that. How does that trinomial factor? 4 and 2, multiplying to be 8, adding to be 6. That's 4 and 2. So it's x plus 4, x plus 2. The denominator, what is it? It's a sum of cubes. Anybody else want to break? So if it's a sum of cubes, what cubed gives me x cubed? What cube gives me 64? 4. Yeah, good, Tucker. Okay? So when we factor that, remember that with a sum or a difference of cubes, there's a short piece and then a long piece. What's the short piece for this one? X plus 4. What's the long piece? Good job. Perfect. What cancels? Yeah, those x plus 4s cancel. Will this trinomial that's over here, will it ever factor any further? No, because it came from a sum or a difference of cubes. You know that will never factor any further if it came from that. So we don't have to worry about factoring that again. That leaves us x plus 2 over that trinomial, x squared minus 4x plus 16. And that we have the simplified version of that. A little bit of funner factoring. Let's throw this one out there. 5x squared minus 10x minus 15 over 2x squared minus 2x minus 12. Let's factor those, I'll say completely, because every one of them we need to factor completely. So with this one, what's the first thing you do on the top? You pull out a 5. Yeah, it's a GCF of a 5. That leaves you x squared minus 2x minus 3. And what about the denominator? 2 is the GCF, so we'll pull out a 2. X squared minus x minus 6. And then we got a couple of trinomials there that don't match. Kind of always want to look for that because sometimes that'll shorten your workload if those trinomials match. They don't in this case, so we need to factor those. If they will, I'm thinking they will because I made the example up, so pretty sure they do. What's the top one factor as? Yeah, x minus 3, x plus 1. The bottom? Multiplying to be negative 6 and adding to be negative 1. Yeah, and positive 2. Add negative 3 and a positive 2. So x plus 2 and x minus 3. What's going to cancel on this problem? The x minus 3s, they're the only thing that cancels. Your final answer is 5 parentheses x plus 1, 2 parentheses x plus 2. And again, you don't need to multiply that back out. Definitely not today. Two x squared plus 10x over 3x squared plus 16x plus 5. Let's simplify that. What goes on here? What's the top? Pull out 2x, good. What's left in the parentheses? X plus 5, good. Now in the denominator, is there a GCF? So we got to factor it with X method, multiplying to be 15 and adding to be 16. 1 and 15. So does that mean my factors are X plus 1 and X plus 15? No. I can't go to that shortcut. Why can I not use the shortcut on this one? Yeah, that 3 in the front screws it all up. So I'm going to put plus 1x plus 15x plus 5. So we're going to have to do the grouping on that. 3x squared and 1x have x in common. Leaves us 3x plus 1. 15x and 5 have 5 in common. So my factors are 3x plus 1 and x plus 5. Works out kind of handy because what cancels? Yeah, the x plus 5 is cancel, leaving us 2x on the top and 3x plus 1 in the denominator. Several methods of factoring that we've seen so far with this stuff. Really got to know all the ways of factoring when you're doing this. They don't get just crazy hard factoring problems inside of this, but you got to know the basics of factoring. All right, so let's talk about find the product. What does that mean? Multiply. So we're doing multiplication, and we're multiplying fractions. Okay. So let's look at an example with just numbers where we're multiplying fractions. So like 3 over 28 times 21 over 18. Okay. So we got to think about what are the rules for multiplying fractions. What are the things that you're allowed to do when you multiply fractions? Yeah, numerator times numerator, denominator times denominator. So in its most basic form, you can just multiply straight across. Kind of want to avoid doing that because we're going to put polynomials in here. And when you multiply polynomials together, what happens to them? They get bigger. Okay, we don't need them to be bigger. We're trying to make them smaller, right? So what's another option that you have when you're multiplying fractions? How can we use that? So Brandon said greatest common factor, and that's part of this. How do we use that? How can we cancel when we're multiplying? Like instead of just multiplying straight across and then reducing the big fraction we get at the end, how can we cancel along the way? Yeah, the cross canceling is what we can do there. So you would look vertically to see if you could cancel. 3 and 28, nothing. What about 21 and 18? They're both divisible by something? 3. They're both divisible by 3. So I'm going to reduce vertically. That's going to be a 7. This will be a 6. Okay. And then what's the other direction? There's only one other direction that I can cancel. I did vertically.
3 and 6.
Yes, diagonally is the other way. That's exactly right. The 3 here can cancel this 6 here. You can cross cancel vertically or diagonally, never straight across. Okay, so 3 goes into itself 1 time, into 6 2 times, and now we got a much easier problem to multiply out. 1 times 7 is 7, and then 28 times 2, not a huge number, 56. Oh, the 7 and 28 could simplify too. Let's back up. 1, even easier problem to multiply now. 1 times 1, I got that. 4 times 2. So we've simplified that fraction with not ever having to multiply 28 times 18. Because who knows their 28 times tables? Nobody. Or nobody that can talk to people. Okay, so you just don't know. You don't have to do that. You're looking for cancellations here. The rules for cancellation are vertical or diagonal. Okay, so we're going to throw some polynomials in there or some variables, and we're going to look for those sort of things. Okay, so it can get a little messy looking sometimes when you're cross canceling and things. So don't ever think you can't just stop where you're at and rewrite the problem with what you've got now. Okay, so don't think that you can't do that. So let's say we had 8x to the 5th y over 2x y squared times 7x to the 4th y to the 3rd over 4y. So a lot going on here. My method of doing this is always look vertical first and then do diagonals, because it's a little less messy to do it that way, and nobody needs a big mess in their life. So vertically, what about this fraction vertically? The y's, this y here can cancel how many y's on the bottom? One of them. So this is not a 2 anymore. It's now a 1 with y to the 1st power. This one is gone. What else? 1x here cancels 1x up here. So that's not a 5th power anymore. It's 4th power. What about the 8 and the 2? 2 goes into itself 1 time and into 8 4 times. Sometimes it's helpful to just rewrite the problem with what you got left. And I'm going to do that here. You don't have to, but I think it's helpful sometimes. Got a y on the bottom there. Before I write the second fraction, I'm going to do it vertically too. What the y's, this 1y down here cancels one of these up here to make that y squared. So 7x to the 4th y squared over 4. So I canceled vertically, and then I rewrote the problem just to keep it from getting too messy. Now, I've already done all the vertical stuff. Now I got to look diagonally. This y cancels how many of those? 1. Okay, so this one's gone. And it's left with 1. The 4s, this 4 cancels that 4. What's left in the denominator? Nothing is technically a 1. Okay. So on the numerator, though, we've got an x to the 4th power here and an x to the 4th power here. So together that would be x to the 8th power. Good. And then we've got the 7 times 1. And then don't forget your y that you had left there. Technically, this is over 1, but we don't ever have to write that if it's over 1. So we've simplified a pretty ugly problem to begin with down to something that's, not too bad, not too intimidating. And that's our idea here, is just try to do that. Say we had 5x squared y to the 3rd over 3x y to the 4th times 27 x to the 5th over 15 x to the 4th y. What's going on there? All right, so vertically, what can happen on the first fraction? The y's, we got 3 y's up top, 4 y's on the bottom. How many are gone? These 3 cancel how many of the 4 that are in the bottom? 3 of them. So this is actually not y to the 4th anymore. It's y to the y or y to the 1st. Okay. What about the x's? Yeah, this one cancels out one of those, so it's x to the 1st. So we got 5x over 3y. That's what we got left for that one. Let's do vertically on the other one. X's, 5 on top, 4 on the bottom. How many are left and where are they? All right, so this one cancels out completely. This one cancels out to make a 1. What else can cancel? Both divisible by 3. So that's a 9 and a 5. So that's 9x over 5y. So I've done my vertical cancellation. I've rewritten it so it's easier to read. And then now I can do diagonally. The 5's go. The 9 and 3. 3 becomes a 1. 9 becomes a 3. These are both 1s. What about the x's? They go together to make, yeah, so it's 3x squared up top. What on the bottom? Y squared on the bottom. Good. Not too bad. I think these are more difficult than the polynomials that we're about to do because there's more parts to them. The polynomials, it's back to what we've already done. It's factoring. So let's look at some polynomials for multiplying. X squared plus 4x over x squared plus 8x plus 16 times x squared minus 16 over 5x. So we're taking a couple of polynomial rational expressions and we're multiplying them together. Now, we'll take the same approach. We're going to try to cancel vertically and then diagonally. We don't want to multiply straight across because it's going to create just a really large polynomial. And we just took a test on that, and that stuff's kind of difficult sometimes. Once the polynomial gets so big, there's only so much you can do without having to employ some pretty interesting ideas. So the idea here is to factor as much as possible on every spot. So let's factor that first fraction. What's the numerator? How does it factor? That x squared plus 4x. Is it, you mean a difference of squares? No. Good idea because it don't have 2 terms. But it's got what, Tucker? I could bring out a GCF of an x and leave x plus 4 in there. So GCF, always look for that first. That's the simplest factoring that can happen. So always look for that first and then go to your other methods. So the top part's x parentheses x plus 4. The denominator, it's quadratic. 3 terms multiplied to be 16, add to be 8. 4 and 4. 4 times 4 is 16. 4 plus 4 is 8. So that's the right one. So it'd be x plus 4, x plus 4. And then I'm going to go ahead and factor the second fraction. X squared minus 16. Jaden, I'm going to say you meant this one is a difference of squares, I hope. Yeah, that's what I thought. All right. So, well, how does that factor then? x plus 4 and x minus 4. Does 5x factor the denominator there? And nothing you can do to that. Just leave it 5x. Now, cancel vertically. So vertically, this x plus 4 can cancel one of these x plus 4s. Is there anything vertically that can happen on this fraction? No. Now, this isn't too jumbled like the other stuff was, like the ones that weren't polynomials. This is pretty organized here, so I don't think I need to rewrite it after I've done vertical. I can go ahead and do my diagonal stuff. What's going to cancel diagonally? X plus 4 cancels this x plus 4. This x cancels that x. What's left? That's it. So we took this pretty ugly math problem here and reduced it down to not too intimidating of a fraction. That's our idea today, is try to get down to the simpler things. Let's look at this one. N. 20x minus 5x squared over x squared minus x times x squared plus 3x minus 4 over, let's do that fun one again, x squared minus 16. Tucker? Okay, yeah, that's not in descending order there, so we need to think about it in that direction. So that'd be negative 5x squared plus 20x. That'll make it easier to factor, I think, hopefully. So how do we factor that? Negative 5x squared plus 20x. Take out a 5x. And here's the trick. Because when we rewrote it in descending order, the leading term was negative, our GCF needs to be negative. So we're going to pull out a negative 5x. That'll help us when we go to simplify here and cancel some things out. Because if we don't pull out that, if that leading term, the leading coefficient is negative, you want to pull a negative out with your GCF to get things to cancel the right way. So that'll leave x minus 4 in the parentheses. It changes that sign in the middle when you pull that negative. What's the denominator of that fraction factor as? GCF of x, leaving x minus 1. Let's factor the other fraction. X squared plus 3x minus 4. What are my factors? X plus 4, x minus 1. What's the denominator factor as? Again, I usually do vertical stuff first and then diagonal. So the obvious one that jumps out to me is this one. Get rid of that. And then on this one, I got 5x and x minus 4 and x minus 1. Obviously, these don't match, but this x and this x do. So they cancel each other. And then I go to diagonals. Yeah, that x minus 1 cancels that x minus 1. That x minus 4 cancels that x minus 4. All of that stuff reduces down to negative 5. Factoring is the vehicle that makes this happen. The donut example. X plus 2 over x cubed minus 27 times x squared plus 3x plus 9. Well, the second part's not a fraction. How can I make it a fraction? Yeah, just put it over 1. Makes you feel a little better, more comfortable. Now, let's factor what we can factor. So if we start with the first fraction, x plus 2, does it factor any way, shape, or form? No. What about x squared minus, or x cubed minus 27? It's the difference of cubes. And what cubed is 27? 3. 9 times 27 and 9 is 3 and 3. Yeah, I know where you're going. And then, so what are the factors for the denominator of that one? Short piece, long piece. What's the short piece? X minus 3 plus 9. Good. All right. Always it's a memorized pattern, guys. There's really not a method to it. It's a memorized pattern. What about this trinomial here? Does it factor? No. 9. Nothing multiplies by 9 has to be 3. So that's just x squared plus 3x plus 9 over 1. And then I look to cancel things vertically first and then diagonally. Anything canceling vertically? No. Diagonally. What? Yeah, this trinomial cancels that trinomial. So those two factors match. And that leaves us x plus 2 over x minus 3. We've simplified. Three more examples, folks. We'll be done. X cubed plus 8 over x minus 2. X squared minus 4 over x squared minus 2x plus 4. I'm throwing in some sums and differences of cubes because I know we need the most practice for that. We just haven't done much of it. So x cubed plus 8, kind of gave it away, is the sum of cubes. X cubed plus what cubed? 2. So the short piece, long piece for that. What's the short piece? X plus 2. It's always going to match. Plus, plus. And then the long piece, x squared minus 2x plus 4. That looks familiar. X minus 2. Now, what about the numerator on the second fraction, the top of the second fraction? X minus 2, x plus 2. Denominator there, we got x squared minus 2x plus 4. Will it factor? No. We know it won't factor because there's nothing that multiplies to be 4 and adds to be negative 2. We also know it won't factor because it matches that. There's really no need to factor it even if it would. So if you got matching pieces there, you don't have to save you a little bit of work sometimes. So canceling things that cancel. That and that. What else? That's x minus 2 cancels that x minus 2. Do these x plus 2s cancel each other? No, they're side to side. They're horizontally, so they can't cancel. So it's x plus 2 times x plus 2. That's acceptable. How else could you write that? X plus 2 quantity squared. That would be the other way that it would be acceptable to write that. plus 2 quantity squared. All right. Okay, so multiplication, we got our rules. Factor everything, and then simplify vertically and diagonally. And that gets you what's left. Okay. Let's look at division. And the quotient. All right, so we got to remember some rules. We won't do nearly as many examples of this because we just got to remember, what does division by a fraction turn into? By which one gets flipped? The second one. Then it's the same rules for multiplication. Once you flip the second one, it's multiplying again. Follow the same rules. 5 3/5. Let's throw a polynomial involved. 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. You can. JP asked a great question. Can you factor before you flip it? It doesn't matter. When you factor, just flip. At some point, you have to flip the second one. I usually do the flipping first and then do my factoring. Maybe because that's just the way my teacher taught me to do it, but it doesn't matter what order you do that in. I'm going to write it flipped first. Because a lot of times, the reason I remember Miss Campbell telling me you want to flip it first and then do your factoring is because you'll do that all that factoring, and then you'll get in a hurry and forget to flip it, and you'll just start canceling things before you flip it. And if you don't flip it, the factoring is not true. A lot of canceling stuff. So 7x, and then that would be 2x minus 5. I'm going to get the easy ones. What's that trinomial factor as? Good. Multiply to be 30, add to be negative 11, be negative 5 and negative 6. And then you can start canceling stuff. I got an x and an x, x minus 6 and x minus 6, x minus 5 and x minus 5. All's left 7 over 2. Division, not any harder than multiplication, just one extra step. Flip the second one, multiply. Okay, so no need in doing 20 examples of that for sure. Hang on just a second. Number 6 through 43 on page 577 is where it starts. That'll get all of that stuff, so we're going to do all of those. You got about 30 minutes left in class today. You can get started on it. You probably want to do a few problems there so that Monday, when you're doing work day, you can try to make sure you got all your questions answered before you quiz on Tuesday of that stuff.